Example 12. The points P, Q and R are collinear, so they're telling us this is collinear. Find the ratio in which Q divides PR. Now, this question in an exam is either on its own or it's tagged on to the end of a collinearity question. So they're telling me that we have a line and I've got P, I've got Q, and I've got R. Okay? And they are collinear. So that tells me that vector PQ and vector QR must share some components. Because that's what collinearity means. Now, if we want to find the ratio, I need to find what portions belong to each vector. So the first thing we're going to find is vector PQ, which is Q minus P. Now, I still write this when I'm teaching it. If you've stopped writing the Q minus P, that's okay. But I keep going because that's how it's in my brain. Okay, so we are 8 minus 3, 1. Minus P, which is 6, 1 minus 3. If we subtract them, we get 2 minus 4, 4. Now, what do we notice about 2 minus 4, 4? They're all in the 2 times table. So I'm taking 2 out, terrible 2. Gives me 1 minus 2, 2. When we're doing components like this, we're always looking to find, do we have a common factor? And then we're going to work out what vector QR is, which is R minus Q. So we are 9 minus 5, 3. Subtract 8 minus 3, 1. My handwriting's horrendous. Gives me 1 minus 2, 2. Oh, so that's what QR is. I don't have a common factor this time. So that's telling me that PQ is 2 lots of QR. Okay, so essentially my common factor here is 1. So I've got 1 on that side, I've got 2 on this side. So that's then telling me on my diagram that PQ is twice the size of QR. So there's 2 in that one, 1 in that. That becomes my ratio. Okay? So we're then saying that Q divides PR in 2 to 1. You don't change the numbers when you're doing a ratio.